This block diagram illustration depicts a typical three-phase AC variable speed drive system. It has three main components: an operator control, a drive controller, and an AC motor. An operator control device provides a means to start and stop the motor and adjust the operating speed. The drive controller consists of a variety of components that work together to convert an AC input into a frequency and voltage output necessary to change the speed of an AC motor. Let's look more closely at the components of the drive controller. The converter or rectifier component consists of an array of fast-acting switches that convert an incoming AC voltage to a pulsating DC voltage. The intermediate circuit acts as a filter and consists of a DC bus and associated circuitry. This stage of the wave conversion serves to stabilize and smooth the pulsating rectifier output to generate a constant DC voltage. The filtered DC bus voltage then passes through to the inverter. At the inverter, an array of fast-acting switches convert the DC bus voltage into pulses at a constant magnitude that are proportional to the DC bus voltage. In a typical three-phase frequency inverter, there are 6 switches, with a pair of switches for each phase. In each pair of switches, one switch generates the up component of the sine wave and the other generates the down component. The inverter output is not a true sine wave, but an approximation based on the application of pulse width modulation, or PWM. The longer a switch is on, the higher the AC output voltage. Conversely, the longer a switch is off, the lower the output voltage. This duration of on time for each pulse is called pulse width. The time duration and intervals of these DC voltage pulses determine the synthesized AC output voltage and frequency. In a three-phase driver, the sine waves produced by each pair of inverter switches are 120 degrees out of phase to ensure efficient operation of the motor.